one categorization, that is what? That is the homosphere and heterosphere, homogeneous layers or heterogeneous layer. So homosphere is extended from 0 to 80 kilometer. You will get a clarity with respect to the heights as well. So the troposphere, which we used to see, which is the topmost layer to the Earth's surface, the height of troposphere is around 10 to 12 kilometer. The height of troposphere is around 10 to 12 kilometers. See, there is no exact, we can say, there is no exact number with respect to the outermost border of troposphere. Okay, we have a variation from 10 to 12 degree. At some places it could be 10, at some other places it could be 12. Okay, troposphere, the height of troposphere from the Earth's surface extended up to a height of 10 to 12 kilometers, sometimes 15 kilometer as well. Okay, then after the troposphere we have a one different layer, and that layer is what? Stratosphere. So the height of stratosphere is up till the 50 kilometer. The height of this particular stratosphere is till 50 kilometer from the Earth surface. Okay, now it is not exact, again, because in geography nothing is exact. Some processes used to be changed. Okay, because of the variation, because of the lack of universalization, it's geography. So what we can say, that up to a 50 to 60 kilometer we have a height of stratosphere. Then similarly up to the height of 80 to 90 kilometer we have a one different layer which has been given name as mesosphere. This is the stratosphere. Then after this 80 to 90 kilometer we have like this almost 120 kilometer. At that particular level we have a thermosphere. We have what? Thermosphere. So with respect to the pattern of temperature, again, with respect to the pattern of temperature, what we can say, that if you are on Earth's surface, because of the behavior of volume in troposphere itself, what will happen? The temperature will become fall based temperature will become fall by 6.5 degrees Celsius per kilometer rate, and that rate is based on the volume of air. I hope you remember. So as the troposphere is actually denoting one specific set of density of air, however the volume is contrastingly different, so the behavior is there. And yes, there is a continuous follow-up of lapse rate, but if you are in the stratosphere, instead of decreasing temperature further, temperature used to increase. This increase in temperature is because of the ozone layer, which is present, See how ozone is being formed. Here we have oxygen in troposphere. Yes or no? We have oxygen in troposphere. So we have oxygen in troposphere. Now this oxygen will receive what? This oxygen will receive UV, ultraviolet radiation. When this oxygen will receive ultraviolet radiation, what will happen? That this oxygen will be split. Oxygen monoxide will be there. Suppose we have another oxygen. So we have this action with these molecules of oxygen, and as a result of this, what will happen? There is a oxygen monoxide is formed. Now this oxygen monoxide will going to react with the nearby oxygen molecules, and that's how there will be a formation of what? Ozone. Now here in this specific case, the conversion of oxygen in ozone is being facilitated by whom? It is being facilitated by this insolation. So here what we can say, that it is because of the ozone layer, which is actually formed by absorption of ultraviolet high energy sunlight. And if when we have a high energy sunlight and if it will going to absorb, so temperature will be high. So it is because of the ozone, it is because of the absorption of ultraviolet radiation by oxygen to form ozone. As a result of this, what will happen? As a result of this, temperature will going to increase instead of decrease. So here we have what? Here we have a reversal of lapse rate, that instead of decreasing temperature with increasing height, here the temperature is increasing with increasing in height. As the height increases, temperature increases. As the height increases, temperature drop by 6.4, 6.5 degrees Celsius per kilometer, lapse rate. Here it is increasing. Why? Because of the ozone layer. And yes, you might be surprised that here we have a one different zone. We have a one different zone, which is basically being called as pause. The density difference is not taking place all of sudden. The density difference is not taking place all of sudden. You might have seen sunrise and sunset. They are not taking place abruptly. For example, at 6 o'clock, or let's say 5:59 sun is there, and at a 6 o'clock sun will be suddenly set. It is not there. Extreme events are not there in geography. Extreme events are not the feature of geography itself. There are always smoother events. So what we can say that first there will be light, then there will be a sunrise, and then sun will reach to its zenith during the afternoon. So there is a gradual process, specifically in natural things. So here we also have what? A gradual pattern in which for a period of time the density is not going to change. The density will going to remain same with respect to these consequent, or let's say with respect to these successive or this particular layers associated with it. So that particular different distinguished zone is being called as what? Pause. Pause. That for a certain height, the characteristics of air will remain same. Now that is just a kind of discontinuity which we discussed in interior of our earth. Those discontinuities, those discontinuities were marking what? Those discontinuities were actually marking the different density of rocks. So here we also have a different density of air which is being marked by a one particular zone, and that zone is being called as what? Tropopause. Then after, the temperature will going to increase, okay, because of the ozone layer formation, because of the ozone layer itself, because of the absorption of ultraviolet radiation. Now the energy will be here in the stratosphere, so temperature will going to increase as the height increases. Reversal of lapse rate, it is also being termed as temperature inversion. You'll have a clarity in upcoming slides. Then when this, if we reach at the height of 50 kilometer, after that we have a same uh, zone which is actually distinguished, which is actually responsible for separating two different layers in terms of mesosphere and stratosphere. That is being called as stratopause. That the features which are here, they will take a pause for a period of time. The temperature which was decreasing, here it was same, then it started to increase. The temperature which was supposed to decrease based on the lapse rate, it was remain same, because the features are what? Pause. They will get pause because we have some sort of same set of air layers. Then when, if we move in mesosphere, based on lapse rate, the temperature in mesosphere, the air's temperature in mesosphere will going to fall. Air's temperature in mesosphere will going to fall. Air's temperature in mesosphere will going to fall based on lapse rate pattern. Then again, if we are in thermosphere we have what? Charged energy particles. We have some charged electromagnetic particles. We may have some sort of ultraviolet radiations. We may have some sort of X-rays from the celestial bodies, from the sun itself. In terms of solar flare, we can also have some electromagnetic radiation, and because of that radiation, when it will going to absorb by the air, the air's temperature will going to increase. Air's ionization will take place, and as a result of this ionization of air, what will happen? the temperature will going to increase. So in thermosphere, after this pause, which has been called as mesopause, the temperature will going to increase significantly. So this is the behavior of temperature based on the characteristic features at the different altitude. Now, with respect to the gases, with respect to the temperature pattern, with respect to the other things, our atmosphere can be divided. I hope there is a clarity. Our atmosphere can be divided in two ways. Our atmosphere can be divided in two ways, and the ways are, we have a homosphere. We have what? Homosphere. So homosphere is from 0 to 80 kilometer. I mean, till the mesosphere, you can say. It is comprised of gases. Obviously, the gases are there, though their density, their volume, their pressure characteristics are different. Troposphere, stratosphere, mesosphere are actually being counted as what? Homosphere. That there are uniform concentration of these gases. Yes, we also have a CO2 even in the mesosphere. Yes, we have, but majority of the part is concentrated in the troposphere. Heterosphere means what? Like whenever we have a some sort of non-uniform gases, when we have a non-uniform gases, when they are concentrated, that is being called as what? Heterosphere. So gases, when they are separated by molecular diffusion because of the intense charge activity of sun. Suppose here we have a air. Suppose here we have a air, and with this air, because it is, you know, uh, because it is the among the top most layer. So here from the sun we will have what? Electromagnetic radiation. We have a charged particles, and with this charged particle, this air will going to what? Charge, ionize. As a result of this, temperature will increase. As a result of this, temperature will increase, and this process we are referring as what? Molecular diffusion. Okay, and as you know, gravity is here, so we will have some sort of more gas, I mean the heavy gases, and here we'll have what? Lighter gases, because the gravity's influence will be less up to that particular height. So lighter gases are dominating at the higher altitude. They are easy to what? They are easy to ionize, because if they will get a meager energy. With that, even they can be ionization. Thermosphere and exosphere. Basically, after the thermosphere, we have one more layer, that is exosphere. So thermosphere and exosphere are the part of what? Heterosphere means there is non-uniform gases concentration. I mean, the gases are basically being ionized. Charged particles are also there. So this composition is contrastingly different from homosphere. Okay, so that's how, based on the characteristics features, based on the gases concentration, we have this categorization. So this categorization is based on composition, that our atmosphere is comprised of what gases, our atmosphere is comprised of what material. I mean, in terms of density, in terms of volume, etc. So accordingly, we used to categorize. Then, then